So we have to go from rapidly rising to falling and falling all the way to zero. This equation has four factors, a little bit of multiplication. So you've got a thing on the left, CO2, that you want to get to zero. And that's going to be based on the number of people, the services each person's using on average, the energy on average for each service, and the CO2 being put out per unit of energy. So let's look at each one of these and see how we can get this down to zero. Probably one of these numbers is going to have to get pretty near to zero. That's back from high school algebra. But let's take a look. First, we've got population. The world today has 6.8 billion people. That's headed up to about 9 billion. Now, if we do a really great job on new vaccines, health care, reproductive health services, we could lower that by perhaps 10 or 15%. But there we see an increase of about 1.3. The second factor is the services we use. This encompasses everything: the food we eat, clothing, TV, heating. These are very good things. Getting rid of poverty means providing these services to almost everyone on the planet. And it's a great thing for this number to go up. In the rich world, perhaps the top 1 billion, we probably could cut back and use less. But every year, this number on average is going to go up. And so overall, that will more than double the services delivered per person. Here we have a very basic service. Do you have lighting in your house to be able to read your homework? And in fact, these kids don't, so they're going out and reading their schoolwork under the street lamps. Now, efficiency, E, the energy for each service, here finally we have some good news. We have something that's not going up. Through various inventions and new ways of doing lighting, through different types of cars, different ways of building buildings, there are a lot of services where you can bring the energy for that service down quite substantially. Some individual services even bring it down by 90%. There are other services like how we make fertilizer or how we do air transport where the rooms for improvement are far, far less. And so overall here, if we're optimistic, we may get a reduction of a factor of 3 to even perhaps a factor of 6. But for these first three factors now, we've gone from 26 billion to at best maybe 13 billion tons. And that just won't cut it. So let's look at this fourth factor. This is going to be a key one. And this is the amount of CO2 put out for each unit of energy. And so the question is, can you actually get that to zero? If you burn coal, no. If you burn natural gas, no. Almost every way we make electricity today, except for the emerging renewables and nuclear, puts out CO2. And so what we're going to have to do at a global scale is create a new system. And so we need energy miracles. Now, when I use the term miracle, I don't mean something that's impossible. You know, the microprocessor is a miracle. The personal computer is a miracle. The internet and its services are a miracle. So the people here have participated in the creation of many miracles. Usually we don't have a deadline where you have to get the miracle by a certain date. Usually you just kind of stand by and some come along, some don't. This is a case where we actually have to drive at full speed and get a miracle in a pretty tight timeline. Now I thought, how could I really capture this? Is there some kind of natural illustration, some demonstration that would grab people's imagination here? I thought back to a year ago when I brought mosquitoes, and somehow people enjoyed that. It really got them involved in the idea of, there are people who live with mosquitoes. So with energy, all I could come up with is this. I decided that releasing fireflies would be my contribution to the environment here this year. So here we have some natural fireflies. I'm told they don't bite. In fact, they might even not even leave that jar. Now, there's all sorts of gimmicky solutions like that one, but they don't really add up to much. We need solutions, either one or several, that have unbelievable scale and unbelievable